Alright, so today we are going to work on day 2 of this mini unit. Make sure if you were paying attention, you're looking at the mini unit, that you can see it's only going to last us about 6 days. So it's a very small unit. We'll be finishing it next week. Before I start on today's, just remembering, since you did this lesson over the weekend, remember when you have a right triangle, so this is pretty simple with Pythagorean theorem, but it's you have side A, B, and your hypotenuse is C. So because it's a right angle triangle, what we know is A squared plus B squared equals C squared. And we're going to continue to use that. Yesterday, or the homework that you graded for today, was just the path of the Pythagorean theorem. So now today we're going to use that to make triangles so we can find distance. And this is fairly simple for what we're going to do. So the first one says, on a school playground, the slide is due west of the tire swing. All right, so I'm going to draw a picture of this. So if here's the slide, let's say like this is point S. If the slide is due west of the tire swing, well, west, north, east, south, west, that means it's to the left. And due west means it's straight. So due west of the tire swing. So I'm going to say the tire swing's over here. I'm going to call that T. And due south of the monkey bars. All right, so that means my monkey bars have to be up here. And when it tells me that it's due south, that means it's straight, which means this formed a 90-degree angle. Since it was due south and due west, those would meet to make a 90-degree angle. If the distance between the slide and the tire swing is 6 meters, so slide and tire swing is 6 meters, and the distance between tire swing and monkey bars is 10 meters. Okay, tire swing and monkey bars. So we need to connect this line, and then it's 10 meters. How far is the slide from the monkey bars? So they want to know like the distance there, and we call that C. Obviously, we have a right triangle, so we would say our side squared times side squared. So we have 6 squared plus C squared equals 10 squared. And solving this, you would have 36 plus C squared equals 100. And we just solve it like any equation. Let's subtract 36 from both sides. And we get C squared equals 64. Huh? Oh. Yeah, you're right. It should be like B, shouldn't it? It, to be honest, doesn't really matter because it's just a variable. But we get, when we always did it, we write S squared, but it's alright. You're right, that would be B. C, we're always saying it's hypotenuse. So, B squared. And we undo an exponent being squared by square rooting. And the square root of 64 is 8. So you would say your answer is 8 meters. Okay, on today's, we are going to have to use our calculator at times because not all of our answers are going to come out to a whole number. So when that happens, make sure that we are writing a decimal point in, unless it tells us where we are rounding to. So today's goal, Denny, get this open so you can follow along with us in our notes. Today's lesson is I can apply the Pythagorean theorem to find distance in the coordinate plane. This actually is theorem. It's funny enough, last night, even when I was going to read for this, Pythagorean theorem, do learn it because you will use this in real life just for random stuff. I was watching a thing about carnival games and how they were scams. And it was, and they're showing you how different ones. Well, the one they were showing was like the basketball shooting one. And I know this isn't part of our lesson, but it was kind of interesting. They were showing how a 3-point line, if I have a basketball hoop here, I stand here, from here, the distance to a 3-point line, if anyone knows, is 24 feet. And how tall is a basketball hoop? 10. So then when I'm standing here, and I have to shoot from here, right? So I should be able to find that distance. If I would do, so this is my right angle, so I'd have 10 squared plus 24 squared has to equal my c squared. And if I do this, this is funny why I'm doing this, even though it has to do with our class, so sort of. So 24 times 24 is 576. So 100 plus 576 equals c squared, 676 c squared. So 676 square root is 26. So my distance, when I shoot, this distance my ball's traveling up is 26 feet, right? Well, they said on the carnival game, they went and measured it. It's the one that you can see at Worlds of Fun or whatever. They have the basketball hoops and the things drape into you. They say the one reason it's draping towards you is so you can't stand underneath the hoop and see. The hoop's actually, when they measured it, 11 foot tall. And, oh shoot, what was the distance? 28 feet, I think. I think so. They had the distance at 28 feet. So they were talking like muscle memory. If anyone's practiced shooting, like that's why a lot of times people don't even like they just catch when they shoot. It's muscle memory. Their arm kind of knows how hard and everything to throw it. Well, so if we went with this equation, 11 squared plus 28 squared. So that's like 121 and 28 times 28. 178 or 784 plus 121 equals square root 30. What in the world? 30.1. So then your final answer is 30.1. So you're finding that you're trying to shoot the ball upwards and a farther distance of another 4 feet, which if you've ever shot a basketball or you're trying to do that, it's actually kind of a big difference to be changing. So it was kind of interesting. I loved when I watched this because they used the Pythagorean theorem to show this. And I was like, oh, I'm teaching that tomorrow. So this is why we can actually use this in real life. So now you can be carnival games. All right, let's show how we're going to use it on a coordinate plane. So if I'm asked to find the distance between 2 points, and the points are 2, -3, and 5, 4, we've seen this before, and I've seen it where students have done this incorrect, where they're trying to find the distance, and they say, here's the first point at 2, 3 on a coordinate point, here's 5, 4, and then they go, okay, well, you can't really guess. So they start trying to piece these together. And they're like, well, if I put this piece with this one, I think that equals 1. And then they start just guessing how much it is. Sometimes if we're just estimating, it might work. But for when we need an exact answer, we need to have a method. And that's where the Pythagorean theorem comes in. Because between the 2 points, we have this edge. So what they do is we just connect it, making it a right triangle. It's kind of how, when we first were working with slope, we did our rise over run. If I ran over to where they're lined up, and then I go up and down, I form a right triangle. Straight up and down, straight left and right. We look at pretty much what our slope is. That height was 7 units. The run was 3 units. So I could just transpose this triangle to right here. and I know I have a 7 and a 3 in my hypotenuse. So then they show their work right here for you guys on your OneNote. So hypotenuse squared equals a squared plus b squared. We replace it with 3 squared and 7 squared. You get 9 plus 49 is 58. Square root that, and we would find that the hypotenuse is approximately 7.6. So the distance between the points is about 7.6. And if we didn't know if it was feet or inches, we would call it units. That is what we're going to try today. Now, let's see if I can trick anyone. How about this first one? Without shouting out your answer, it says, find the distance between each pair of points whose coordinates are given. Round to the nearest tenth, if possible. Don't shout it out, but go ahead and find, what do you think the distance is between these 2 points? When you have it, you may raise your hand so I can see who is ready. Does anyone have it yet? Hmm?
Why would you need it if it's already a straight line?
What do you mean?
Can't you just count the units?
Yeah. If I go here, is there a need to use the Pythagorean theorem here?
No.
No. They want you to make sure you understand this, that when you look, even if I had a third point, let's say a point was here, and they were asking us anything, we don't have to overthink anything. If it follows a straight line, it's not cutting across, and I can obviously tell that 1, 2, 3, 4, 5, 6, 7, then we just say it's 7 units. Those are the ones on our coordinate points that we are allowed to just straight up count because they don't cut across the square. We know how big each distance is. Number 2, I promise you, is not as easy. Well, it's not hard really, but this one we can see that my line between 2 points, I have 4, 3, and I have negative 2, 1. It does cut across, so I don't know how the distance is on each one, and I want to find it. So, once again, all we are going to do is we are going to make a right triangle. I'm mainly drawing how we used to find our rise and overrun. I go straight down from one point, so I'm even with the other point, and over. Then I can look at how did I transpose that triangle. So I'm going to just move it over here so I can see what I'm working instead of working on the coordinate, or instead of on the coordinate plane. But this height was 2 units. The run was 1, 2, 3, 4, 5, 6. I can write my equation. 2 squared. That should have been 6 squared. That should be 6. 2 squared plus 6 squared equals c squared. And that's all we're going to be doing today for the most part. Showing how we're going to take a line and make a right triangle out of it, and then use our Pythagorean theorem. So this is 4 plus 36, 40 equals c squared. So I square each one and get 6.3. So we would say that our answer, the distance between the points is about, or wait, did it come out exactly, Maddie?
No.
Okay. So about 6.3. Make sure you put your label. Yeah, I put about, since it didn't come out to exact, that's why I was asking. They found the answer for me. Since it did come out exactly 6.3, I'll just go ahead and type that in. So we had 40 to the square root. Since it came out to this, since I'm rounding it to the nearest 10, that's when I would say about. If it came out to exactly 6.3, I'd just say 6.3. Alright, so number 3, chess. April's an avid chess player. She sets up a coordinate system on her chessboard so she can record the position of pieces during a game. In a recent game, April noted that her king was at 4-2 at the same time as her opponent's king was 7-8. You actually see, if you play chess, I've played it, but if you are an avid chess player, when they do strategies, they do want to know distance between their pawns and kings and pieces. So she wants to find out how far apart they are. So she'd first take her points, 4-2 and 7-8. Once you have your 2 points, she wants to know that missing distance. Once again, we just create a right triangle out of the whole thing. And I'd be able to say, that's our C. 1, 2, 3. 1, 2, 3, 4, 5, 6. And I'd write my equation. 6 squared plus 3 squared equals C squared. 36 plus 9 is C squared. 45 is C squared. Type it in, and you hit the square root. So I'd say 6.7. Use that little wavy equal sign to show that it's an about. So I would say about 6.7 units. Please make sure to put your label. Okay. Should be fairly straightforward what we're working with. So we're going to hit up a new part. And this part should still be reviewed. So today we're covering 2 parts. 1, how to use the Pythagorean theorem to find the distance between 2 points on a coordinate point. And then measures a central tendency, the mean, median, mode, and range. These should sound pretty familiar and you should understand this. So let's just make sure. What is mean? Average. What is median? Middle number, but there's something important about that one. You have to put them in order from smallest to greatest. Mode is which one gets repeated the most. And then range is the biggest minus the smallest. So let's go ahead and see if you guys can do this first one. I'm going to pause. The first thing I would do, though, is over to the side, I always go ahead and I'm going to write them in order. And me, personally, just that thing I've always done, when I rewrite it, I cross it off to make sure I don't use it again. So I'm going to pause my video, see if you guys can do this, and then we'll discuss. If you have any questions, make sure you ask. But it sounds like you guys got new. It should be a review. I'll pause our video now, and then we'll come back to check your answers. Alright, so I'm not done with one of them, but I want to make sure to discuss them. So, find the mean. You guys should have gotten your answer to be 2.4. I think the exact answer, what we say, 2.425. So, definitely not a 7 point something. So, remember, to find mean, add up all your numbers, and then you divide by how many you added together. Median, this is the one I have not finished. So, median, when we have an even number of data, we know we're going to have to change something. So, when I always list them out, I always crossed off on each side. So, I was saying like, okay, this one came off, that one came off. But we have 2 left. We go ahead and you find the average between the 2 that are remaining. So 1.8 plus 3.2 equals divided by 2 is, so my median would be 2.5. So if you ever have even numbers, you know you're going to end up averaging. Mode, you would say none. Mode just is the one that repeats the most. Since they all repeat the same amount, let's make sure we understand that part. That they all repeat the same amount, there is no mode. Not just because they're only listed once. If each number was listed 3 times, we'd still have no mode. Even though they're all repeated 3 times, we would not have a mode because none of them are different. Can you have more than one mode? Yes. If 3.3 was repeated 3 times and 1.4 was 3 times, we would have 2 modes. We'd say 3.3 and 1.4. Our range, the highest minus your smallest number, which tells me in between my scores, my highest score, my lowest score, I have a difference of 1.9 of our units. Okay, so this quick goal that we're going to work is determine measure of central tendency is the best representation for data. So, frequency table. This is kind of important because we want to make sure we do this right. On a frequency table, we have all these data points. What we do is we have these little, I always call them tables. I think this major's called them buckets. We made out this table. I actually made mine just a little bit different always. Wait, and I'll show you why, and we'll do that later. But, test score. In our test score, we're going to make a range. That's what we're going to write in there. So we're not just going to put one number in. We have to get something that's going to cover all of our data. And it's just like when we did a scale on a graph. It has to stay consistent from each one. So we do not want to say 60, 65, 70, and so on. What we want to do is have a range. So this is going to have a range to it. So, for example, what I would do is I'd find my smallest number is 60. And I would say in this box, I'd say anything that is between 60 and 64. So my next box, we would say 65 to 69. Then I'd say 70 to 74. 75 to 79. 80 to 84. 85 to 99. 90 to 94. And 95 to 100. If I needed to add more boxes to it, we could. Now, one mistake I've seen with students doing this, they've done 60 to 65, 65 to 70, 75 or 70 to 75, 75 to 80. What is the problem with that? Okay? Good. So if I would have, and I've seen this before, someone's done 60 to 65, and then 65 to 70. I've seen students, I've seen teachers even do this before. And we're like, well, if I have 65, which bucket does it go in? So you have to make sure that you're not repeating. All right. So when we do this, I just go through. Okay, 60. And I'm going to put tally mark, 65, 270s, 60, 65, 80, 85, 90, 95, 100, 85, 60, 65, 80, 95, and 100, 80, 290s, 100, and 80. And so you just make your tally marks there. You can, and there isn't one, and that's okay if nothing got covered in there. We have tally marks, and we can go ahead and write in them. The one I was telling you I've seen different, and like usually what I have used in the past when I'm doing stuff like this, instead of saying test score and frequency, instead of frequency, we would say tally. And that's where you do your tally marks. And then underneath is we made a whole new box. And that's where we wrote in frequency. And then I went through and said, okay, there's 3 there, 3 here, 2, 4, 2, 3, 5. This can be just 0 if I want. So that might be just a little bit of a change that you see. But if we're asked to make a frequency table, that is the most important thing that I have to be doing. I want to make a range. Now, is my range set in stone that it had to be 60 to 64? You should know that answer. Could I have made it 60 to 69, 70 to 79, 80 to 89? Yeah, that would have been totally fine to do. Our data would have just looked a little bit different then, because I would add more clumps in each group. If you wanted to make it smaller and go every 2, that's fine. So it's up to you on your range, but you usually make it so it's most manageable. We don't want to have it too small because then we just have small groups and we don't really get anything out of it. We don't want it too large where we have too many pieces of data where everything just has one. It doesn't help us any. So this just kind of groups them together. All right, last thing. Finding an unknown number. And this used in college a lot, trying to make sure I could get my grades correct. But it says, Mike had test scores of 84, 93, 89, 92. He wishes to have an average of 90 on all his tests. He needs to have a 90. He has one more test to take. What score does he need on his 5th test in order to earn a 90? We're going to let X represent the 5th score. What equation do you think we could do? How can we find out what does he have to earn? Do we just guess and keep putting numbers in there? What can we do? Since we're going to find we need to find out his average. He wants it to be 90. So I'm going to go 84 plus 93 plus 89 plus 92. Okay, plus X.
And then you would divide all of that by 5. And then it would be equal 90.
This is the equation we want to use. Because this is how we find the mean, the average. You're going to add all those scores. So the numerator is all of our scores being added together. 84, 93, 89, 92, and whatever his score is. And when you take those 5 scores and we divide them by 5 and we find the average, we want that average to be 90. Now, when I go to do this, my first step would be I want to get rid of that division. So to undo that in my equation, I'm just going to times this whole side times 5. Since I was dividing by 5, I'm going to multiply it by 5, which means I have to go on this side of the equal sign and times by 5. This would undo my 5. 90 times 5 is 450. And if I added all this up, did anyone add those already for me? 358. So we'd have 358 plus X equals 450. You would simply subtract 358 from both sides. X would equal 2. He would have to get a 92 on his last test. Yeah? Yes. Okay. I know we went over about 3 things. 1, finding the distance 2 points on a coordinate graph by creating a right triangle and finding the Pythagorean theorem to find our side squared plus side squared equals hypotenuse squared. We then worked with central tendency. Make sure we understand on our frequency table that we need to have a range first and then collective. Your homework for tomorrow, use the Pythagorean theorem to find the distance on a coordinate plane worksheet and central tendency worksheet. So it is on OneNote. I also have the copies. It's front back. Yeah?